So today we'll be talking about second order partial derivatives. In the previous video I covered how to partially derive or differentiate, but I didn't talk about the second order and what the notation I was doing was. So traditionally, calculus 1, you'll have some function f of x, let's just say f of x equal to x to the power 4. And if you wanted to notate the first derivative, you would put a single prime symbol. Correct? If you wanted to differentiate this again, you put two prime symbols. It's very simple. But inside of multivariable calculus, you will derive like this, with this notation. So you will have some subscript of x. This means you derived once with respect to x. You have two x's. You derived twice with respect to x. So you derived the f of x function with respect to x. So you basically just derive the equation twice with respect to x. This means you derive with respect to y, and this means you derive with respect to y twice. How about this? What if you did f of x, y? Well, if you have a function, let's say for an example, actually give an example here. Say you have a function, for example, ln of x, y plus y to the power of 3x here. This is equal to f of xy. You're going to derive twice with respect to x. And if you want to figure this out, well, let's go ahead and find the first order partial derivative with respect to x first. So what is that? Well, we're treating y as a constant. So all we're doing here is putting this at the bottom of a fraction, because that's derivative of ln. And we use chain rule inside of here. And since y is just treated as a constant, chain rule only applies to x squared. Plus y to the power of 3 times x. And if you derive with respect to x, well, since you treat y as a constant, this isn't changed at all. It's technically the coefficient of something. So let's say you want to derive 6x. This would just turn to 6, right? Well, 6 in this case is just our y. So it's treated as a coefficient when it is, or a constant when you're deriving with respect to something. That's not the y value. So this can actually simplify into 2 over x y plus y to the power of 3. What if we want to find the double derivative with respect to x both times? Well, we just derive this equation again. So we derive f of x with respect to x. How do you do that? Well, treating y as a constant, and we're using power rule here, and we get this. Because technically this is 2 times x to the power of y, x times y to the power of negative 1. And if you use power rule here, you just bring the 1 down, negative 1 down, and you multiply. You subtract the power by that, and this is what you get. These two are equivalent. How about y to the power of 3? Well, when you're deriving with respect to x, you're treating y as a constant. So if y was, let's say, something like 6, for example, what would you do with that? It just turns into 0. So this is the entire double derivative with respect to x twice. So this is the second order double derivative. What about with respect to y? Well, we're treating x as a constant now because we're deriving with respect to y. So what is this? Well, technically, x is just a constant. Oh, I did this wrong, I think. I did. Hold up. Made a little mistake here. Just notice. This is what it is. So it would just be, the y would just cancel out, so you just ignore it. There you go. Yikes. Okay, let's derive this again. So you're deriving f of y with respect, you're deriving f with respect to y now. So you're treating x as a constant. What do you do here? Well, since x is like kind of a coefficient, it goes on the top of this ln. plus, so you're deriving with respect to y, x is a constant, so it's just 3xy to the power of 2. And this is also equal to 1 over y. These x squares cancel out. So these cancel out, and these cancel out. So you get 1 over y plus 3xy to the power of 2. You have to derive twice with respect to y, so you just derive the y derivative again with respect to y. So you treat x as a constant again. Since y right here is technically y to the power of negative 1, we can use power rule, and this turns into negative y to the power of negative 2. What is that? That's just 1 over y squared. Plus 3x turns into this. Because you're using power rule only on y, x is treated as a constant. This is our double derivative with respect to y. How about with respect to xy? Well, you have to look at the x partial first and derive this now with respect to y. Since you're deriving this with respect to y, and since x is a constant, treat it as a constant when you derive this with respect to y. This simply just is a fraction, so this turns into 0. But this right here turns into y, 3y to the power of 2. Let's solve for the other combination, f of y, x. Now if you derive this, go to the y, derive this with respect to x, what do you get? Since this is treated as a constant, and this is treated as a constant, we get 3y squared. Because y is treated as a constant, this just looks like a fraction to us, like maybe 1 over 1. And since we're deriving with respect to x, y is treated as a constant, so technically this is something like 3y squared x, and this portion right here is the coefficient in this case. Whenever you just derive whenever you derive a function with a first order magnitude of exponent, then the coefficient is just the only thing that's left over. So notice this. These two, f of xy and yx, look the same. Well, in most cases that you'll probably see in your classes, the x partial with respect derived with respect to y and the y partial derived with respect to x are going to be equivalent. And I don't remember the conditions. I don't know. They're probably on ChatGPT or something like that. But in most cases, you're going to have the same thing. Okay, let's derive x squared sine of x plus 3yx plus cosine y squared. Good lord. You know what? This is going to be an annoying one to do, so I'm just going to remove the y squared because I'm lazy. Okay, let's find the... set this up first. F of xy. So how about f of x and f of y? Well, let's derive this. Well, you have to use product rule here because they're two of the same functions, right? And since we're deriving with respect to x, x is treated as part of the function, and y is treated as the constant. So let's use power rule here. Product rule, sorry. Plus, and now we're moving on to the next thing. So this right here is the derivative of this. I'll actually color code that for you guys. And 3yx derived with respect to x is just 3y since x is treated as a constant. And cosine y is simply a constant because y is treated as a constant when you're deriving with respect to x. So it just turns out to be 0. Can I erase these underlines? Yeah, there you go. Okay, let's derive with respect to y now. Well, if you derive with respect to y, this right here is treated as a constant, so it turns into 0 because there's no y values here. And if you derive this with respect to y, you get 3x. How about cosine? Well, you get negative sine of y. So now we have our single order partials. We just have to derive the partials again. So we have to derive this again. Again, we have to use product rule. So I'm going to use product rule for this. 2x cosine x. So this derivative right here is this derivative. Plus x squared. Actually, it's negative x squared sine of x plus 2x cosine x, and 3y is treated as a partial because we're deriving with respect to x again, so this is our full derivative since this just zeroes out. So this is our double second order partial derivative with respect to x. How about for y? Well, we just have to derive this again with respect to y. Let's go ahead and do that. Since we're deriving with respect to y again, x is treated as a constant, so this zeroes out. This is turned to 0. But sine is not. So derivative of sine is just cosine. We'll leave the negative in there. How about the xy partial? Let's start with the xy partial. Let's go to the x partial, and we derive the x partial with respect to y. Since these right here are x values, and we're deriving with respect to y, these are constant, so they zero out. And all we're left with is 3y. If you derive 3y with respect to y, you just get 3. How about we try again? F of y derived with respect to x. Let's derive this with respect to x. Since y is treated as a constant, since we're deriving with respect to x, this turns into 0. And all we're doing is deriving 3x. We've derived 3x with respect to x. You just get 3. And again, these two values are the same. So for the next problem, let's see what it is. It will be, let's do this one last one. Xy plus e to the power of x sine of xy is equal to f of y, xy. So let's set up all our equations. xy, yx. Okay, let's derive with respect to x first. So, since we're deriving with respect to x, y is treated as a constant. All we do is use power rule on x squared, and you get this. Since x, right here, is not treated as constant, it's within both of these functions, you get to use product rule. So let's use product rule here. Sine xy plus e to the x. It's actually, since we're using chain rule, y times e to the x cosine of xy. We notice we use chain rule inside of the sine value, so we are just deriving the xy value. If you derive xy with respect to x, then all you get is y that's out of the function. So this is our x partial derivative. How about our y partial? Well, our y partial is, since x squared is treated as a constant, it's just the coefficient in this case, and y is just y to the power of 1, so we just get x squared. And e to the power of x now is a constant, so we can just leave that alone, and we can derive cosine. We can derive sine to get cosine. Now, don't forget, again, chain rule. So, we have to use chain rule on this. We're deriving with respect to y, so x is treated as a constant, and since x is the coefficient in xy, x gets chained out. So these are two single order partial derivatives. What happens if we find the double order x partial? Well, we have to take this x partial again, and since x is just x to the power of 1 and y is treated as a constant, 2y is this section's partial. And we have to use product rule again on everything here. Holy shit. Cosine xy times y. Alright, since we're using chain rule here and x is treated as the y is treated as the constant. And y is treated as a constant again, so y can just be left alone, and we just do the partial like this. E to the power of x. Oh my god, this is going to be so long. E to the power of x cosine xy plus, actually this is minus e to the power of x sine xy. Alright, you get the point. Okay, you get the point. This is it. I'm not even going to finish this, bro. This is way too long. I don't know why I made this practice problem for myself. Okay, xy. yy. Okay, let's find yy. So we find the y partial of this. Since x squared is the constant here in this case, guess what we have to do? Well, this turns into 0. Derive a constant, turns into 0. So we have x e to the power of x treated as a constant, so we just leave that alone. It's technically the coefficient of this function. And we have x in the front as well, so let's just actually just move x to the front. So I just moved the x to the front here. And all we're doing is deriving with respect to y. So since y is inside the function of cosine, we derive cosine. You get negative sign, that's why I put the negative in the front. But don't forget the chain rule. When you chain the function xy, technically, like this is what I mean. You find the derivative of xy, and this turns into x, because you're deriving with respect to y here. And if you derive with respect to x, this x gets multiplied by another x to get x squared. Okay. This right here is very, very annoying. I'm going to not touch that. But we can derive the x partial with respect to y. Let's try to do that. Let's derive the x partial with respect to y. So we get 2 xy. So we're deriving with respect to y. X is treated as a partial. X is treated as a constant. So this derivative is 2x. Ugh. And e to the power of x is a constant. Sine has the y value inside of it, and we must chain this, and we get x on the outside. Y is treated as the constant. Y is treated as the, what is it here? The function here. So we have to derive, and we just move the e out. That's why we put the parenthesis. We have to derive y with the function cosine xy. So y's derivative is just 1, so we just get cosine xy at first, plus leave y the same, and we derive cosine xy. But since we have to use chain rule, we're deriving with respect to y, we have to move the x to the outside. So this is our xy partial. What if we derive y with respect to x? This is very annoying. I don't think they're equal to each other. I don't know. I might have done something wrong, but you guys get the point. Y to the power of x. Yeah, no, not y to the power of the y partial with respect to x. So we derive this. This is just power rule. Plus ex. Oh god, this is triple product rule. Okay, we'll try it out. X. You know what? Put that shit in a calculator, bro. I'm not doing that, bro. I'm going to sleep. Okay, good night, guys. Hope you learned something.